All right. Now we want to make sure invalid inputs are handled. So this can get interesting. Let's say we were making a test, invalid product. And we're saying we're going to be missing price. Okay. And then do end. So we're going to create a product with just a category. So category electronics. All right. And then we're going to say discounted product equals, and then let's say call our discounts module and apply our discount to the product. All right. And we want to make sure, actually we're going to make the category toys because we want to just do assert, and we want to make sure our discounted product is equal to our product. But we want to make sure it's handling a missing argument, right? Or I should say key value. So save this and let's run our tests. So mix test, and oh no. So we got a key error, price not found in our map. So we want to make sure we gracefully are handling missing parameters so we get what we expect back, right? So if we go and look at our discounts, we can, like that we created, we notice that pricing category. So let's go here. So you notice price is always going to be needed. Category is always going to be needed. This is the only one that requires both price and category, right? And then the other two are just price. So we could just add a guard to our applied discounts rule, right? We could go into our DSLR. We could go into our DSL, our discount macro here, and where we apply the rule here, we could just do a guard here. When is map key, and we can just say from the product we're looking for price, and then we can do and is map key, and in our product map we're looking for category. All right, so we could do this, and then so if this guard doesn't match, it's going to need a fallback. It's going to need a fallback option function to go to. So we need to create another apply discount rule. And this time we're going to just take a product, and we don't care what the condition and action function is. So we can just put an underscore there. And then what we're going to do is we just want to return the product. So this way, if we're missing price or category, we're just going to return the product without doing any adjustments. Okay. So now if we save this and run our tests again, undefined variable. Oh, I have a typo. Undefined variable, apply discount. Oh, there's my typo in our guard product. Okay, save it. And now let's run our tests. And look, now we're getting a passing test. So we fixed that. And now when we look at our tests, this is working. This is great, right? But does anyone see a problem with this solution? We just hard-coded required fields, and depending on what fields are required by the module using our macro, we can't do this. So you have to remember, we wrote this macro to be reused by any module, right? And this module just happens to be using our macro, and it happens to use price and category to apply discounts. But what if our macro doesn't calculate discounts based off category and price? It could be different values. So how can we refactor this to know what fields are required for our discounts to be calculated? So we could have our discount macro accept an additional argument. We could maybe take a list of required fields, which I think is probably a pretty viable option. So what could happen here is if we go to our macro, we have our discount right here, right? We're taking a name, our condition, and then the action. We can add one more argument here. Right after name, we could just say required fields. All right. And then we also have to add it to our bind quoted here. So we have our required fields and then our required fields. All right. And then we also need to make sure it goes into our at discounts. So it maps correctly. So then pass in our required fields. So we updated that. So now when we create our discount in our discounts.ex file, we have to add an extra parameter here. See, we're already getting yelled at that it's looking for it. So what's cool, now we can just create our list here, right? And we can say, well, price is required on this one, on this discount. And then we can come down to this one, our electronics, and we can say, well, price is required and so is category. And what's cool with doing this is, we're going to make that an atom, is we can apply discounts, excuse me. So let's pretend we're missing category. We can at least apply the other two discounts without not applying all of them and ignoring it. So this gives us a little more control. And then if we come down to our last one here, this one also just requires price. All right, cool. Whoop, we lost a comma. All right, so cool. We're now we're passing in our required fields for our discount, which I think is really cool. But now we need to refactor our apply discount a little bit. So we're going to have to create a private function that is going to validate our product. So we need to go through the required fields list to do our validation, right? So let's go underneath our apply discount. Make sure you're within the quote because this is all happening in our before compile. Okay, so make sure you're within our quote do block and just under our last applied discount rule. And we're going to say def p and we're going to say validate product. All right, and this is going to take a product and our required fields. If I can spell required fields. Okay, and now inside of this, we can use a nice little function from the enum module called all. This takes an enumerable and an anonymous function. So the enumerable that we need to go through is the required fields. And then we want to just make sure, so as we are enumerating through the required fields, we want to check that our product has that key. So it could be 0 keys, 1 key, 2 keys, because we don't know what required fields is, right? And we can do that with our shorthand here. We can do the ampersand, and then we can say map dot has key. And what we're going to do here is pass in our product and then the ampersand 1. The ampersand 1 is whatever index we're on in the linked list. So if it's price, this is going to be price, and it's verifying that that price key is in our product. All right. So we wrote our validate product function. So now we have to use this. We need to refactor our applied discount rule. So we don't want these guards here, do we? So let's delete that. That was, it was a good attempt, but it limited our macro to being too hard coded, right? So now we have to think about this. We want to validate our product. So as long as this returns true back, right? That means it has all the required fields. and then we need to apply our condition like before. So we need to do two things. We need to validate product and still validate and still apply the condition to our macro at compile time, so we know that it's there. Hi, I'm Jacob. My YouTube channel and podcast reach thousands of engaged Elixir developers every month. If you're looking to promote your developer tools, services, or job opportunities to a focused audience of Elixir professionals, head to elixirmentor.com and let's discuss sponsorship options. We can put this in a case statement instead of an if statement. And what we can do is create another function that is going to validate our product and then apply our condition all in one go. So why don't we do that right now? We'll make another function and we'll say validate underscore and apply. And this is going to take our product, our required fields, and our condition function. And then do an end. And now inside of here, we can just do a simple if else statement like we're doing up here. But we're going to do it here. So we're going to say if, and now we're going to validate our product. So validate product, and we're passing in the product and the required fields. And then do an end. And if we get a true back from our validate product, then we want to apply our conditional function. So the same thing that's happening here. So I'm just going to copy this. We're just going to break that for now, right? And then we're going to do that here. So we're just changing things a little bit. And then if we have an else block here, we're going to return an atom called skip. All right. So after we apply, if it validates our product, we need to do an and. So we're going to and do this because we want to return apply discount atom. So we're just returning a label essentially that we can match against in like a case statement. So if everything happens in order of operation here. So if validate product is false, it ends. If it's true, it moves on, and we'll do our apply function with our condition function at compile time. So just like what we were doing before, we'll just return the apply atom. And if those don't pass, we're going to return a skip atom. And I don't know why this end is there. We don't want that. Okay, save. All right. So now that we're getting whether we apply our discount or skip our discount, things are looking good, right? So up here, I'm just going to delete this. We'll keep our apply discount. So the action function is where we're actually applying the discount. So if we do a case statement here, we can do case, and we're calling our validate and apply. And then we're passing in our product, our condition, our required fields. And I just realized that we have to also add to apply discount our required fields, which will already be there from this right here. All right. So we have our case statement, and we get atoms. We get response atoms back, right? So, we need to pass in our condition function as well. What did I call it? Condition function? Condition func? Yeah. We're going to call this condition func just to keep our syntax the same. And I even wrote condition func here because I copied and pasted. So we just caught a little bug or a compile error. All right. So our validate and apply will return the apply atom if that's what happens. So we can just do our apply case right here, apply, and then do our little dash greater than. Awesome. And then if we get our skip, we can do our dash greater than, and then if we're skipping it, we're not applying a discount. We're just going to return our product as is. All right. So now if we save this, we have our discounts here. All right. So if we run our tests, this test should still pass because we removed our atom, or, our hard-coded guards. But now that our test is okay, let's see. Unexpected, we have too many ends. All right, so the fun of refactoring. Oh, that's what happened. I forgot the do at the end of our case. And this end is needed there. Okay. We had the end and no do. I thought it auto-completed. All right, so now let's run our tests. And look, we have 6 passing tests. So we removed our hard-coded guard, and now we're just passing in our required fields, which is much more versatile now to use in any module, which I think is pretty cool. All right, so we have one more problem with how we're testing our macro, though. We are testing it through the callers module, and our callers module is this discount.ex module, because see how we're using our macro, and then we're using our discount macro and passing in our functions here, but we wouldn't have access to this or even know what discounts would be created here. So we have to use integration testing with a nested module. So since our module is required to use our discount DSL, we can embed a module directly in our test module that uses the discount DSL. So when Elixir loads the test, our nested module will be compiled with all the generated function definitions, and then we can make integration level assertions around its behavior. And all we have to do is we can just copy and paste our discounts module and place it inside of our test file. Now we have so if I just do this, copy, and we go to our tests, and just right underneath our use, inside of the test module, we can paste our discounts module. And now our integration tests are done. So our old discount module can now be altered or removed, and our tests will still work. And what this does is it allows us to use our macro and apply, use cases that we can test against that won't change. Because a major problem here, so I'm going to just name our discount, the one in our tests, discounts test, just to avoid confusion here. Test, so discounts test. Test. So now if I save this, our tests will still pass, and we're using a nested module, which I think is really cool. And so this gives us the ability. So like now anyone using our macro, so let's pretend we change something here, right? Like what if we don't want a 10%, we want a 20% discount, and we want to do a 10% here, and free shipping is 30. Like these changes would break our tests that we wrote for our macro, and we would be changing, like right now we originally were writing our tests off the callers module, which doesn't make sense. But now that we have our embedded module, we're testing off of this, and this compiles with our test at runtime, which is really cool. So now if we do mixed test, it still passes, even though I just changed this criteria, which if we were still using this, they would all fail. So like now imagine if I undid all these changes and we were calling discounts and not discount tests, and then I save it and we run our tests, they would all fail. Yeah. So 2 failures, they wouldn't all fail, but you get my point. And that wouldn't be a very robust testing implementation, would it? So we're going to go ahead and just go back to using document test. Boom, boom, boom. Save it. And then I realized our first test here needs to, oh no, we're just making sure the macro loads, which is fine. We'll leave that. So there we go. We just wrote tests to make sure our DSL macro works, which is pretty cool. So great job. You've learned how to set up and run tests for our own discount DSL. I don't know why I keep wanting to say DSLR in Elixir using XUnit. So remember, simplicity is key in both programming and testing. Complex, brittle test suites can be a nightmare, especially in large projects. By keeping tests simple, you make them clear and maintainable, serving as valuable specifications for your program. Well-written tests are often the first thing to look at when exploring a new library. So remember that, and I'll see you in the next video.